Sir,
So yes,
sir, you record the classes. Where do you send this? Means where do you keep this
sorry,
recording? Sir, where do you keep these recordings? Means do you post it on YouTube or something like that?
which one?
These recordings, these class recordings.
Yes, I do.
Okay, sir. Okay, sir.
No, I do. Upload these recordings to YouTube. You didn't know that?
No, sir. No, sir. Actually, that's why it's asked.
Okay. Okay, originally I would put them in my Google Drive and share with the respective class, but later somebody pointed out that it is difficult for them to download the videos at once, because in YouTube you can watch it in different different resolution or different data speed. So that's why I have started uploading them on the YouTube. Acha. Um, uh, Now I'm going to deviate a little bit from the plan that we had on last Wednesday. That is, we are supposed to solve a set of problems using NT coordinate system, that is normal tangent coordinate system, and then we would proceed for the polar coordinate system for curvilinear motion. But what I'm planning on doing today is start with the derivation for the polar coordinate system. So. So after that, you would solve problems relating to each of the coordinate systems. So now we are studying particle dynamics first of all. In that we are studying kinematics, and we are trying to capture the curvilinear motion. And for that now we are going to use the polar or r theta coordinate system. By the way, the curvilinear motion is only planar. Okay. In our syllabus, we only have planar curvilinear motion. Okay. So, so the idea is that, let's say these are the x and the y axis, global x and y axis, and let's say this is the path that the particle takes, which is currently at P, and let's say at P, its position vector is given by R. Okay. uh, and if I were to represent that using the polar coordinate system, so this direction is the unit vector for the radial direction. And you can, I hope you can appreciate that as the particle moves to a different location, let's say somewhere called P prime, then you have a different position vector, R prime, let's say, and then the unit vector also along that direction would be different. Okay, it is going to be different than the current one. Um, of course, in addition to that, you have your theta coordinate over here, and in addition to this, let's say P and P prime are at a distance of d theta. Okay, so it's the distance between the two is differential. That's all I'm trying to say here. Uh, so so this is how the position vector is given for uh, for the particle in polar coordinate system. So you only need, if you recall, in normal and tangent coordinate system, the velocity could be given by only one unit vector. Here the position is given by only one unit vector, that is r times er, and then the velocity v would be the time derivative of r, which of course has two parts, r dot er, and then r er dot. Now we'll come to this part. Um, or rather we should look into this part. um, so so let's say this is the er direction, and e theta direction, e theta direction is this one. So this is how E theta works. E theta is essentially K cross ER. So unlike in normal and tangent coordinate system, where the normal direction has a fixed normal direction would be always towards the center of rotation. Here it is not mandatory. You can uh, simply take a direction which is at positive 90 degree or counterclockwise 90 degree from the radial direction, and then you have your E theta. Okay, and let's say at P prime, this is your ER prime, and at a angle of d theta, and similarly you have E theta prime making an angle 90 degree with the ER prime, and since
Sir,
all of these are yes.
sir, here we are taking E theta cap as a K cross ER cap. So, sir,
Mhm.
is it one kind of assumption because E theta cannot be interpreted as
No,
it
no,
is
no, no.
an
It's not an assumption. This is how we take right-handed systems. Okay, but that is there is only you can say that the polar coordinate system is the the direct replacement for the Cartesian system that you have been taking. Okay, unlike empty coordinate system, there the normal direction has certain purpose because the component of acceleration in normal direction is always positive, and therefore. By taking the normal direction itself towards the center of rotation, instantaneous center of rotation, that you can do justification to the curvature of the path. Okay, so so that is not the case with r theta coordinate system. So r theta coordinate system doesn't have that imposition, unlike the NT coordinate system. So r theta coordinate system simply works like the Cartesian coordinate system. I mean, J is K cross I. It's as simple as that. Okay, so it's it's equivalent to I. Er is equivalent to I. Acha. So what now I can do is take all these 4 unit vectors and construct the circular arc. Okay, and in that I can find this DER, and by now you should be knowing that that is simply d theta times d theta times e theta. And of course, the change in E theta or dE theta is d theta times minus ER. So that is also there, but we don't need that right now. We only need this expression. And this expression tells us that the velocity is r dot ER, and then R. Now, if you divide either side with dt, then you have this quantities. Er dot is simply theta dot E theta. Okay, so one there is r dot and r theta dot. Okay, so basically you have two components of the velocity. One is along the radial direction. One is along the radial direction. I'm not sure what color to choose. Let's take black. So one is this one is, let's say, E. This much is r dot, basically implying how much is now the change in the length of the position vector. Okay, all I'm trying to say here is r prime minus r divided by dt. is your r dot actually. Okay, so one is r dot, the change in the radius, and the other one is in theta direction, r theta dot. Together, they provide you a velocity vector, which is, as you know, tangential to the surface. Okay, so this much is associated with the change in the angle. So the first part r dot is associated with the change in the length of the position vector, and the second part is associated with the change in the orientation. Okay, so r theta dot, and these are the two components of the velocity. Okay, so we can proceed even further and write the expression for the acceleration. Okay, this component right here is vr, and this component right here is v theta. So if the if the somehow for a given path, if you are moving on a circle, of course this r dot would be 0, and and then the velocity is simply r times theta dot. The acceleration, let's say if I now I'll have to take derivative of all the five different quantities that are there. There is r dot, er, r theta dot, and e theta. So let's take the first term, and from the first term we have this r double dot er, and then we have r dot, then the derivative of er, which is theta dot e theta. Then in the second term we have r dot theta dot e theta. So basically this term appears twice, and then you have r theta double dot e theta, which is basically the linear version of the angular acceleration. So the linear acceleration due to the angular acceleration, and in the end you have r theta dot squared minus er. Okay, so basically er times r double dot minus r theta dot squared plus e theta times r theta double dot twice r dot theta dot. Now this term right here is called the Coriolis component, and that sort of component arises when you have both linear and angular relative motions. Okay, I believe when you were in school you must have heard about the Coriolis acceleration or the Coriolis force that determines the direction of the wind flow over the globe. So this is that component actually. It is due to both linear and angular acceleration. Sorry, the linear and angular velocities. Okay, so when two objects have simultaneous relative linear and angular velocities or motion with respect to one another, then there is a between the two bodies you have a Coriolis acceleration component. This component right here, so this component you can identify is due to the angular acceleration itself, and this component is basically the rate of change of r dot. So you can imagine this is the length of the position vector, rate of change of that is r dot, and the rate of change of that would be r double dot. Okay, so r double dot is that term right there. This quantity right here, do you know what this term called? This is the centripetal, I may be wrong with the spelling, centripetal component of the acceleration that is necessary for keeping an angular motion. To continue an angular motion you need a centripetal acceleration. So So basically you have these four terms appearing in your acceleration when you are dealing with r theta coordinate system. Now these two terms together will be your ar er, and these two terms together would be your a theta e theta. Okay, so we'll keep all of this understanding with ourselves, and let's proceed for solving problems. Acha, let me know if you have any questions regarding what has just been discussed. Does everything make sense to you?
Yes, sir.
Okay. Okay, so these are the problems on NT coordinate system, and I'll give you the problem statements. So in the first problem, there is that is basically a simple pendulum, and you have been shown that these are the normal and tangential directions of motion. Okay, and the string is 4 feet long and it's not stretchable, which is to say that. The radius of curvature is a constant in this case. Okay.
Sir, can you please
So,
zoom in a little bit?
oh, okay, okay. Can I zoom? Anyways,
Yes, sir. Okay, sir. Okay, sir.
it's visible now.
Yes, sir. Yes, sir.
Okay, okay. So the radius of curvature is constant, and this is the problem statement. Okay, so given theta dot is this much, 2 radian per second, and theta double dot is 4.025 radian per second squared. Okay, these are the values of theta dot and theta double dot. Okay, now you are being asked to find out how much is an and how much is a theta. Sorry, not a theta. How much is at? Okay, now now an we know is v squared by rho. Okay, and at is v dot actually, where v is the speed of the particle. Okay, at is the speed of the at is the sorry the rate of change of the speed. Okay, now just by looking at this diagram, okay, I mean if you want to use r theta coordinate system, that is also fine. Okay, so if you want to look at r theta coordinate system, so the velocity vector is r dot er plus r theta dot e theta, where e theta essentially coincides with et, and so on. But as you can see that r dot is 0. Okay, so the magnitude v, this time scalar, the speed is r times theta dot, which is 4 feet and 2 radian per second, so 8 feet per second. Okay, and then you can go for the expression for the acceleration, and these are, so basically you get to realize that v is mm, 4 times theta dot. Okay, so you also get to realize that that v dot is simply 4 times theta double dot, right? So that is also, you can immediately interpret that. But if even if you want to use the r theta coordinate system, and if you do that, I would rather appreciate. So you have this expression, first of all, r double dot minus r theta dot squared. Okay, and then e theta is your r theta double dot, and then there is twice r dot theta dot. Now this quantity would be 0, the Coriolis component, because you see r dot is 0, and this quantity is also 0. So from that you will get one set of expressions for the acceleration. So you can immediately determine what are the radial uh, and the transverse components of the acceleration. I mean r and theta components of the acceleration. Now, by the way, these are the r and theta direction. So this, of course, is the r direction, but the theta direction essentially coincides with with the tangential direction. Okay, so this is the radial direction, and the theta direction must be at positive 90 degree, counterclockwise 90 degree with the ER. So therefore, it essentially coincides with the ET direction. Okay, so this one is ET and this one is EN. Now you can do that. Okay, so basically you can write AN is minus AR, and AT is A theta. You can directly do that, or for example, I can use this relation that velocity is 4 times theta dot, because the radius is not changing, velocity is 4 times theta dot. So from that I can find out the rate of change of the speed, not velocity but the speed. Okay, and that actually becomes my AT. Okay, you can also check that is same quantity as r theta double dot. Okay, and then there is v square divided by rho, which would be a positive quantity. But as you can see, with ar is a negative quantity because it is r times theta dot squared. Okay, and how much is r times theta dot squared? It is definitely because v is r theta dot. So v squared by rho is r theta dot squared. So whether you go by this set of expression or whether you go by this set of expression along with this set of expressions, you are going to get the same values for AN and AT. Okay, so could you calculate AN and AT?
Yes, sir. Yes, sir.
Okay. Okay, so I guess the first problem isn't that difficult, given that the radius is a constant. Now let's look into the problem statement for the second one, and this is what it says. Okay, so uh, so you can see a rugby player
Sir,
throwing. Yes, yeah.
sir,
Can you not see the picture?
yes, sir, I can see the picture. Sir, I have one question regarding the previous one.
Hmm.
Sir, suppose if the question is given in examination in the NT coordinate system, then
Hmm.
can I use the relation that AN will be equals to minus of AR?
Of course you can. Of course you can. As
Okay,
long
so then I can solve in R theta coordinate system and then I will transfer that into
yes,
the
yes, that is also fine. But while writing, let's say acceleration in r theta coordinate system, or for example, I couldn't directly get the acceleration. I had to go through the velocity. Okay, so all of those, as long as you are showing all the steps and you are writing all the components. Okay, that means you write the complete expression for the acceleration in r theta coordinate system. Okay, and then you show that some of the terms are zero. Okay, unless you do that, then I don't know whether you are simply going by your intuition and making some of the terms disappear, or you are acknowledging that these terms are zero because of this reason. Okay, you see, uh, simply writing that acceleration is I mean, one can directly write this thing that a en and this much et. Now how much en, how much en is yeah, so r times no r times theta double dot et, and one can directly write this expression, and then r theta dot sorry, r times theta dot squared. Okay, one can directly write this expression. Okay, but first of all, these coordinates r and theta are from a different coordinate system, polar coordinate system. Okay, these notations, these are not the notations of the NT coordinate system. So unless you establish that other coordinate system, r theta coordinate system, write the entire expression for the velocity and the acceleration, and then you show that some of those terms are zero, then that is uh, basically what we did. We showed that some of the terms are zero, so only these terms survive because the r is not changing. And in the end, we did a coordinate transformation. Okay, of course, there was a very simple relation that your the normal and the radial direction was facing in the opposite direction, and your theta direction and tangential direction was identical. Okay, so even with that simple relation, you need to first write the expression for the acceleration in the r theta coordinate system, show that which of the terms are vanishing, and then with the terms that are surviving, you need to do that coordinate transformation. Okay, because r theta, r times theta dot square do appear in the r theta coordinate system, but it appears with a negative sign. Why it suddenly became positive with en, that has to be established. Okay, and you cannot directly write this set of expression. That's my point. Okay, as long as you are not missing any step, as long as you are not mm, mm, I mean, that is also another step, right? When you write the complete expression for the acceleration in r theta and then set some of the values equal to zero, that is another step. So as long as you are not missing those steps, I'm fine with uh, whatever expression you choose to write the acceleration. Of course, you can also use the other method in which you just simply argue that the velocity or the speed of the particle is simply because the radius is not changing, r times theta dot, okay, or the 4 times theta dot is the velocity, and then of course the rate of change of, not velocity, the speed, then the rate of change of speed is of course r times theta double dot, because r is a constant. Okay, so you can go from there also, but whichever method you follow, you should respect each of the steps. Missing any steps uh, would make me believe that you don't understand the significance of the other terms that you are not writing. Okay, so okay, so what is happening in this problem? um, Okay, so there is this rugby player who is throwing this ball, making an angle of 35 degree with the horizontal with that much initial speed. Okay, uh, so so first of all, you need to determine the you need to determine one, the radius of curvature, but when case A is when released and case B is when reaches the maximum height. Okay. Now, what do you think your approach should be? There is another question, but before going into there, I just want to know, if I ask you, let's say when released, and if I ask you to, determine what should be um, the radius of curvature, how would you determine that? Now, one thing can be done, which is the brute force method, according to me,
Sir,
which is yes,
sir, from if I take the xy coordinate system and I can find out the motion of the particle in terms of x and y, then
yes,
eventually I
yes,
can calculate
yes, yes,
d
yes,
2y by
yes.
dx 2y.
Yeah, I'm going there. So basically, x is v0 cos theta times t, and y is your basically x times tan theta. Okay, and then there is 1 by 2 g t squared, but you can do this x squared by v0 squared cos squared theta. Okay, so basically you can use exploit this equation to get the the um, radius of curvature, which the expression for radius of curvature being 1 plus y prime squared to the power 3 by 2, and then y double prime. Okay, this is what
Sir,
you want to do, right?
sir,
Yes.
I know that we are doing in a vectorical form, but an equals means the tangential acceleration is sorry, the normal acceleration is equals v square by r could help.
Sorry,
Sir, an equals v square by r can help, sir, in doing this question,
which one?
proving
The previous one?
this one, sir.
Where is the r?
So r we have to find out means r is the means rho means we are at rho.
Rho. Okay, okay. So you
Here
want to
rho is
figure out
also
r.
changing, and
Yes, in this position the tangential is given, and in the highest position there will be only a x component, the x component of the velocity which was there
Yes,
from the
yes.
initial.
Okay. Yes, actually, I'm actually willing to address the statements of both of you. Okay, I believe earlier you were talking about getting the radius of curvature something like this, that is representing y as a function of x. Is that how you wanted to do that? I mean, of course this
Yes,
has
sir,
to
we
be.
can do it that way, but means there are two
Okay,
methods.
okay. No, 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 no. Let me finish. So, I don't know who I am talking to, but the person who I was talking to before, who mentioned that we can get the expression for x and y. Okay. So yes, that is one method where you can write the expression of y as a function of x. Okay, and then you can use this set of equation to get the radius of curvature. But just remember one thing: this needs to be the absolute value. The radius of curvature needs to be absolute value. The other way to do that is to acknowledge that this is the acceleration in xy coordinate system simply looks like this: 0 times minus g. Okay, in xy coordinate system, which is this xy coordinate system, uh, or rather, if I want to use the unit vectors, so these are, let's say, I and j. Okay, and as you correctly pointed out, that this is going to be my et, the direction of the velocity. And since if I extend the path, that would have a curvature towards the right, so an would be in the towards the downward direction. So this should be an, sorry, not an, en. The unit vector along the normal direction would be this one, which would be making 90 degree with the velocity. So essentially making an angle of minus 55 degree with the horizontal axis. So yes, en. You can write et as cos 35 degree I plus sine 35 degree j, and en as en as minus sine 35 degree I plus cos 35 degree j. So the acceleration is, as you are saying, 80 times et plus an times en, right? So therefore you have this equals 80 uh, cos 35 degree minus an sine 35 degree times I plus 80 sine 35 degree minus or plus an cos 35 degree times j. So that should equate to the two components of the acceleration that is in the Cartesian system. So of course the first term should be 0 and the second term should equate to g, and g in British system should be 32.2 feet per second square. So once you equate these two, okay, you will get two simultaneous linear equations in at and an. From that you can solve at and an. Okay, um, once you do that, so once you have the value of an, that is simply v squared divided by rho. So from that you can get the radius of curvature. Okay, now what changes when the object reaches the maximum height? When the object reaches the maximum height, This is the tangential direction. So this time the tangential direction is along I, and the normal direction is along negative j. So that is the difference. Okay, so the difference would be in that situation, a is 80 times I minus n times j. So at that time 80 would be 0, but an would be g, because the acceleration due to gravity is minus g. So n would be g. Okay, and therefore you can then get the radius of curvature from those values. Okay, so that is going to be the difference. So here the angle is 35 degree. At that time the angle should be 0 degree. That is the difference.
So that means we can do the second method for exam. Means
You can do the
easy.
second method, and I would suggest go with the second method. Okay,
Okay.
but the reason I started with the first method was because some of you pointed that out, number one, and number two is because your understanding is somehow influenced right now, many of you, because I've seen that over the years, is influenced by what you have learned in your school, particularly in class 2. For example, when it comes to the radius of curvature, because you already know a mathematical expression for the radius of curvature. Okay, I would suggest for this problem, when you solve as a home assignment, try either method. Okay, and check you get the same result for the radius of curvature. Okay, so both methods are correct, both methods are identically graded. It's just that I think that using the second method would be a lot simpler. Okay, but first method I have seen a lot of people do, because they are still in that zone mentally, using the formula from the school days. So which is absolutely fine, by the way. Acha. There is another part to the question. Compute the uh, compute the v dot at each location. So when released and when reaches the maximum height, compute the v dot. Now what is v dot? V dot is nothing but 80, and that you are essentially doing in the process. Okay, so you don't have to bother about that. Okay, so it says the compute the rate of change of speed at each of the locations, but rate of change of speed is essentially being calculated if you are using the second method. If you are using the second method, that is automatically being calculated. Okay, so that's another reason why one should be using the second method. Okay, are we clear on this problem?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay. So this aircraft, which apparently is launching a rocket or something, uh, it has two components of acceleration. Okay, now don't be shocked That one component of the acceleration is the acceleration due to gravity, and that is 9.66 meter per second squared. Can you tell me why is that? Is it not what we are familiar in seeing?
Sir, it's
Sir, because of the height,
further away
the
from
value of the
Because of
G
the
is
height,
center.
decreased.
yes. Because of the height, because of its distance from the center of Earth, which is significant. That's all I'm trying to say here. Number two, so that is the component of the acceleration, and that you can imagine where is it acting? It is acting downwards, G. Okay, and when you encounter such problems, you need to be very careful with the statement. The second component equals to 12.9 meter per second squared due to atmospheric resistance and is in a direction opposing the velocity. So it is not moving along its nose. It is not moving in this direction. It is the aircraft is somehow moving in the direction the velocity is shown. Okay, so this is the horizontal direction, and it makes an angle of theta, and that the value of theta is also given. The theta is given as 1.5 degrees. So it is somehow moving not along its length. Okay, and the atmospheric resistance, we have talked about this twice before this class. It's called drag force, and drag force always acts opposite to the velocity. So the other component, let's say this is the direction of the velocity, this is your et so called. So the other component is acting opposite to et. Okay, and that one is 12.9 meter per second square. So basically, can you tell me how much is AT? Are you clear? So there are two components of acceleration. The acceleration is given in two components. Okay, but these are not orthogonal or your Cartesian components. That's all. That's the point I'm trying to make here. Okay, so one is the obvious one, the acceleration due to gravity acting downwards. The other one makes an angle of something with the horizontal, and that is opposing the velocity, and the velocity is uh, the aircraft is moving at a direction making an angle of theta with the horizontal, so it is acting uh, in the opposite direction. The problem statement seems a little confusing to me. Second component equals 12.9 meters per second square due to atmospheric resistance and is directed opposite to the velocity. Okay, so it seems a little confusing to me. But let's say if I tell you that these are the two components of the acceleration, okay, uh, can you give me the tangential component of the acceleration? So what you can do is you can resolve this g into the direction an and in the direction en and et, okay, and whatever component is along et, that needs to be added to get at. But this is not what the problem statement seems. It's um, I'm not able to understand the problem statement also. So let's skip this one. Let's skip this problem, okay, and let's move on to next problem. Okay, so the criteria is the maximum acceleration should be less than or equal to 0.7 g. Okay. And you are being asked to find out how much is the L, how much should be the length, or not length, you can say that this car is moving on a sinusoidal path, okay. So I can write the equation of the path. So it seems like this is the equation of the path. Y equals sine of, so 3 times sine of pi times x divided by L. Okay, so if I, let's say, extend this one and extend this line and consider this one as a starting point. So sine, I mean, it doesn't matter. You can take cos as well. So and it is going with, let's say, a constant speed. Okay, so v is a constant. Okay, now can you tell me where would you encounter maximum acceleration? If let's say v is constant, so there is no at is 0, right? At equals v dot is 0. Okay, so the only component of acceleration that you have is an, which is v squared divided by rho. Now, where is the radius of curvature lowest? if V is a constant, where is the radius of curvature lowest? Uh, you can check that that quantity is lowest uh, at one of the maximas or minimas. Okay, so for example, uh, if I evaluate y prime, that would be 3 times pi by L cos pi x L, and y double prime is 3 times pi by L whole squared sine pi x divided by L. Okay. Now, if you evaluate these two quantities at x equals L by 2, that is this much length. Okay. So that is going to give you the maximum radius of, the lowest radius of curvature. So y prime would be 0 and y double prime would be 3 times pi squared divided by L squared. So your radius of curvature is the absolute value, and that is going to be uh, 1 plus y prime is 0.
Sir,
Yes,
sir, shouldn't that a shouldn't be 3 sine 3 cos pi x by L? Because if we consider, means from where L is beginning, if we consider that position as 0, okay,
hmm,
then x means the next obstacle is at length L. So basically, if we put x equals n, then y is coming 0 sine pi. Yes, it is coming 0. So basically, it should be cos, I guess.
it doesn't matter actually. Whether you take cos or sine, you are going to get. I mean, for me, I took this location as my origin. So this is my y, and this is my x, and I took
Then
this as
okay,
the
okay.
origin.
Then okay, sir.
Okay.
Yes, okay. Yes, okay.
Okay. So rho is radius of curvature is the absolute value. So L squared. Sorry. So I should be dividing with y double prime, which is L squared 3 pi squared. So L squared divided by 3 pi squared, okay, is the radius of curvature, and therefore, if that equates to, you know, um, the so this lowest radius of curvature, I should be considering the maximum possible an. So the maximum possible an should be less than zero point 0.7 g. So what is that maximum possible an? So v squared times 3 pi squared divided by L squared should be less than zero point 0.7 g, or that means L should be greater than or equal to uh, 3 pi squared v squared 0.7 g. Okay, now if I take v equal, let's say, 10 meter per second, and g of course is 9.81 meter per second squared, can you tell me what would be the 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 maximum the minimum value of L?
sir, it is coming 431.61 meter.
Okay.
Pardon, sir, what was it, sir? Sir, I missed it.
কি বললে?
মানে স্যার আনসারটা এক্ষুনি কি বললো, মানে 20.7?
431 point
Four
something.
431.61.
ওটা ওটা আন্ডার রুট করতে হবে তো।
Oh, sorry.
হ্যাঁ, ওটা
হ্যাঁ,
মানে
আন্ডার রুট হবে।
ওটা
20.77.
20.76।
Okay.
হ্যাঁ, 77।
Okay. So it is quite doable, right? আচ্ছা, so there are 2 points A and B. Okay. Now the radius of curvature at A is 250 meter. Okay, and distance between distance between A and B measured along the path is let's say 120 meter. Okay, and let's say the radius of curvature at B is 150 meter. Okay, so imagine this tiny car over here. It is traveling from A to B. Okay, and at A it has a speed of 100 kilometer per hour, and when it reaches B, okay, uh, it has a speed of 60 kilometer per hour. Okay, now can you determine AM and AT at A and B? uh, you know between A and B there is uniform deceleration between A to B. So the speed drops from A to B uniformly, or in other words, uh, V dot equal S double dot equals AT at A equals AT at B equals VA squared minus VB squared divided by twice SAB. এটা কি বোঝা গেল? The normal components of course can be determined from the respective velocities. Of course, you need to convert them into meter per second. So this one right here is 27.7 meter per second, and this one right here is how much? 16.67 meter per second. So AN is at A is VA squared divided by rho A, and AN at B is V squared B divided by rho B. এই পার্টটা কি বার করা যাবে? এই নর্মাল আর ট্যানজেনশিয়াল কম্পোনেন্ট গুলো কি বার করা যাবে?
Sir,
হ্যাঁ বলো।
at point A, I am getting minus 2.056 ET cap plus 3.08 EN cap. And at point B, I am getting 1.85 EN cap minus 2.056 ET cap.
Yes, so the AT would be same in
Yes, sir.
either case. আচ্ছা, এবার একটা জিনিস দেখো। So all I'm trying to say here is this problem is doable, right? আচ্ছা, এবার একটা জিনিস দেখো। Let's say if I now make a correction that the center of mass of the car is around 0.6 meter above the ground. Okay, and this curvatures that we are talking about is actually the curvature of the path. So, but not the curvature of the motion of the center of mass. So if you know consider it correctly, you need to take the center of curvature of the center of the the locus of the center of mass. So basically you should be taking a path, okay, which needs to be corrected like this. Okay, now I need you to determine rho b, but listen the problem statement carefully. This time rho b is not given, you are being asked to find out rho b. What has been mentioned is that the total acceleration at A equals total acceleration at B. If the total acceleration at A and total acceleration at B are to be same, okay, তার মানেটা কি দাঁড়ায়? প্রথমত তো হচ্ছে it is uniform deceleration, which means AT at A equals AT at B. Okay, now this one to be same as, I mean, if the magnitudes of the acceleration are to be same, the normal components must also be same, but there needs to be a correction. Of course you can see that when it comes to rho A, I need to add 0.6. Okay, but when it comes to rho B, should I be adding 0.6?
No, sir.
I should not be, right? Because
Subtracting it.
I'm supposed to consider the center of curvature of this red line, and if I do consider this red line, that is actually as we discussed earlier, this rho b is for the path, so that is actually 0.6 less than the path. Okay, so there I should be subtracting 0.6. Okay, so try to solve this problem as well, where you try to find out the radius of curvature of B. তাহলে এই প্রবলেমটা এখন একটু সলভ করো, আমি 2 মিনিটের জন্য আসছি। তো দেখো এখানে রো বি এর ভ্যালু কত পাবো।
রবি কি 90.03 আছে?
আমার তো 54.8 এলো।
এটি তো সেম থাকবে তো, ওটাকে নিয়ে চাপ নেই।
হ্যাঁ, এটিতে চাপ নেই, নর্মাল।
হ্যাঁ, ওটা 27.78 স্কোয়ার বাই 250.6 ইকুয়ালস 16.67।
16.66 স্কোয়ার বাই
হ্যাঁ, বাই
রবি মাইনাস
ওম।
0.6।
হ্যাঁ, তো
তাহলে ভুল আসছে কেন? দাঁড়া দাঁড়া দাঁড়া, লেট মি চেক।
দাঁড়া 16.67 স্কোয়ার divided by 27.78 স্কোয়ার into 250.6।
হ্যাঁ, 90.8 আসছে।
হ্যাঁ, মানে 90.8, 0.6 অ্যাড করতে ভুলে গেছে।
হ্যাঁ হ্যাঁ হ্যাঁ।
হ্যাঁ।
কত এলো রবি?
স্যার, স্যার 90.8।
ওকে, ওকে। আর থিটাতে তোমরা একটু দেখো যে প্রবলেম সেটগুলো দিয়েছি, অনেকগুলোই প্রবলেম আছে। আমার যে প্রবলেমগুলো মনে হয় বেশ রেলিভেন্ট, আমি সেরকম দুটো করাচ্ছি, দুটো বা একটা করাচ্ছি। তো V is 3 feet per second, and it's a constant. Okay. Now, the question is determine. So, what is happening? This there is a slotted arm which is pinned to the ground. Okay, which means it can rotate with respect to the ground but cannot move. Only rotate, and there is this cylinder right here attached with a piston, and the piston is under pressure from, let's say, a, a hydraulic or a pneumatic source. Let's say a hydraulic source, and the piston which is inside of this cylinder, it is being pushed by that fluid. Okay, and to the piston is attached this rod, and that rod is moving at a constant velocity towards the left. Okay, and your particle of concern is A. So this very tip of that rod is your particle of concern, and that is moving parallel to, sorry, that is moving along with the rod, and as it does so, this slotted arm rotates. Now the position of A with respect to O measured along the slotted arm, measured along the slotted arm is R, and the angle that the slotted arm makes with the horizontal is your theta. Okay, so so you are being asked to find out the following quantities: r dot, theta dot, r double dot, and theta double dot when theta is 60 degrees. Another dimension is given, that is the height of the piston from the, or the, the axis of the uh, rod from the the pivot of the slotted arm, which is O. So that height is given. এবার বলো তো এটা কিভাবে সলভ করবে?
Sir, I can take the velocity at point A at minus vi cap, and I can do the component division along r and theta coordinate.
That's actually exactly what you are supposed to do. So this thing is
Then, sir, along the er cap, it will be eventually r dot, and e theta cap direction, it will be r theta dot.
yes. So so when it comes to r and theta, so this is your er. Okay, and at 90 degrees to that would be your e theta. Now let's not bother about e theta. Let's try to get er. Can you get me the expression for er? It is of course cos theta I plus sin theta j. Okay, and if theta is 60 degrees, that is 0.5 I, 0.866 j. Okay, now sorry, this is supposed to be er. Okay, how do you get e theta? Whether the general expression or the specific one, you can get it by simply doing k cross er. Okay, I mean, of course I can figure out the components and so on, but I would not stress about that. I would simply do k cross, and that would tell me it is kj is minus I, so minus 0.866 I plus 0.5 kij. Okay, now this is e theta and this one is er. So I need to use these two expressions. So I can write this thing to be r theta dot er, no, r dot er and r theta dot e theta. Okay, So now if you substitute the expressions for ER and E theta, you will get it in terms of I and J. Okay, so you'll get VA equals probably 0.5 R dot minus 0.866 R theta dot I plus 0.866 R dot plus 0.5 R theta dot J. Now this sum is supposed to be minus 3, and this sum is supposed to be how much? How much should be the J component? The Y component? If I compare with this expression right here,
Sir, it should be 0.
it should be 0, right? So from these two equations, you can solve for R dot and theta dot. If you are wondering how much is R is, or rather R cos
Sir,
theta, R sin theta, R sin theta is this, you know, 0.5. 0.5 as in 6 inches, which is 0.5 foot. So R sin theta is 0.5. From that, actually, you can get the value of R. Okay. Um, so I believe R would be around 0.577. So you can substitute that expression over here and also over here, and eventually you will get the expressions for R dot and theta dot. Now comes the acceleration. An acceleration of A would be R double dot minus R theta dot squared ER plus R theta double dot plus twice R dot theta dot times E theta. Okay. Now again in this case you can substitute the expressions of ER and E theta in these two expressions, and then compare the components of the acceleration with the Cartesian representation. Now can you tell me?
sir,
Yes.
sir, I can say that at point A there is no acceleration, and eventually I can say that the ER and E theta component should be 0.
ER and E theta component should be 0. You are correct. The fact
And
is
from there we can.
the reason the acceleration is 0 because A is moving with a constant velocity. So this is right here is a 0. Okay. Yes, and you are correct. Whether I write it in Cartesian or polar coordinate system, it is 0. So I can directly write these two components to be 0, and from that actually you can get, because by the time you solve the compared the quantities from velocity, you would be knowing all the first derivatives r dot theta dot r you of course know, and theta dot squared, all of these quantities would be known to you. So all you got to now solve for is r double dot and theta double dot from two equations.
Sir, I'm getting theta dot 4.5 radian per
Okay.
second
Okay.
and r dot minus 1.486
Okay.
and r double dot 11.68
Okay.
and theta double dot as 23.17.
Okay. Okay. So, um, so we'll solve another problem, and as usual, you are instructed to solve more problems from whatever has been discussed in today's class or any other class. And if you have any difficulty, any issue related to any problem, okay, so that we would discuss on Wednesday. Wednesday, of course, we have planning of solving little bit of kinetics, but after that we can discuss uh, you know any problem that you have any issue with. So this problem is very similar to the one we did for NT coordinate system. Okay, and we are actually not going to even solve this one. We'll simply discuss this thing. So again, this time a baseball player is throwing a ball, okay, with this much speed right here at a height of 6 feet, and this point right here is the origin. Okay, at a height of 6 feet, he is releasing the ball. Now, the thing is, of course, you know how much is g. G is 32.2 feet per second squared and acting downwards. Okay, the question is, when time equals 0.5 seconds. So 0.5 seconds after the release, okay, uh, determine the following. Now, how would you do that? So x is like v0 cos theta times t, and y is 6 plus v0 sine theta times t minus half gt squared, right? So, hmm, so you can substitute. So r, the position vector, is xi plus yj, right? So you can determine r at t equals zero point 0.5 seconds. And once you have r, you can determine how much is er, and from that you can determine how much is e theta. Okay. Of course, these in the unit vector format. Okay. Now, also Vx is V0 cos theta, whereas Vy is V0 sine theta minus g times t. So you can also know V equals r dot as Vxi plus Vyj. Okay. So you can evaluate V at t equals 0.5 seconds, but then that V is VR ER plus V theta E theta. Okay. Now VR is R dot ER plus R theta dot E theta. Now, from this expression, you will have the velocity in the Cartesian form. Okay. And once you substitute ER and E theta, you will also have uh, this thing represented in Cartesian form with r dot and r theta dot in them. Okay, and therefore, by comparing the components, you can determine what are the values of r dot and theta dot. Now, what is the magnitude of r? That also you can determine. R is essentially square root of x squared plus y squared. Okay. So you know r, you know er and e theta. Okay. Then you can determine r dot and theta dot once you know the velocity itself. Now, for the second order derivatives, you need to uh, get the acceleration, but the acceleration is only this, and in that you'll have to sorry, it's not plus g, it's minus g. In that you'll have to substitute um, ar er plus a theta e theta. Substitute the expression for ar and er and e theta in these two equations. Okay, and if you recall, ar is r double dot minus r theta dot squared, and a theta is r theta double dot plus twice r dot theta dot. Okay, so by now, with comparison of the velocity components, you already know the first derivatives and also the radius. So knowing all of that, you can determine, and knowing the Cartesian components of acceleration, you can determine the r double dot and theta double dot. So do you think this is doable?
That means, sir, at t equals to zero point 0.5 second, we will
Hmm.
calculate all the vectors uh, in the xy coordinate system, and then we will do whatever we have done in the previous questions.
Yes.
Okay, sir.
Okay. So let them be your assignment for the day. I'm sure you'll be able to solve them very easily. Mm. And if you face any problem regarding any of the problem sheets that have been given to you, or anything from the textbook, uh, we will be discussing that on Wednesday. Okay. Uh, so let's stop here.